Okay, thank you very much for giving us the opportunity to present this paper. This is joint work with Karen Helene Ulrich-Mill, UNC, and Andreas Moxnes, basically all my colleagues from Oslo. And in this paper, we look at the global network of container shipping routes and analyze how a local shock, or so say a shock to one of the nodes or links in the network, can impact global trade. And the motivation to write this paper was pretty simple because container trade is really important. So a rough estimate is that 50% of the value of global trade at some point involves container shipping. And people have convincingly demonstrated that containerization has been the dominant innovation in international trade in the past 50 years. And by now, nearly all countries of the world have container ports. And we're going to think about these ports as forming the nodes of the container shipping network. However, what we don't know so much about is how these ports are connected, or in other words, what the shipping routes of a container, say, that is exported from Norway to the US actually looks like. So how the container gets from, say, Oslo to LA. This is, however, of course, important for understanding the bilateral cost of shipping. In particular, because, as I'm going to try to convince you, many of these routes are really indirect in a sense that they involve the ship passing the ports of other countries in between, or potentially even reloading of containers onto other ships in different countries. So thereby, countries, say the bilateral shipping costs of two countries becomes exposed to shocks in third countries, or more general, to the quality of the infrastructure of third countries in between. So we want to think about how important this is, so whether the container shipping network and its implications for trade costs are important for understanding global trade patterns. And our contributions are threefold. So the first is that we exploit a novel data set that is satellite data on container ship movements to describe salient patterns of the container shipping network. And then in the second step, we're going to think about this kind of the global implications that local shocks to this network can have with the help of an example, namely the Panama Canal expansion that happened in 2016. And thirdly, we are going to provide a quantification of the trade and welfare effects of the Panama Canal expansion. Here's a preview of what we do and what we find. So the first step is that we use this satellite data to find all direct routes, by which we mean all the port pairs where we see ships traveling nonstop between the ports. Moreover, what the satellite data also reveals to us is that the time it takes for ships to complete this nonstop journey. And with these two ingredients and the shortest path algorithm, we in the next step compute all the fastest indirect routes for the country pairs that do not have direct connections. And this kind of forms the basis for the shipping network that we describe in great detail in the paper. Just a summary of what we find is the network is really sparse, so direct connections are very rare, and the more common case is that countries ship indirectly, involving stops in other countries. Moreover, we find that shipping activity is highly concentrated. And these findings imply that at least potentially we have local shocks can generate big impacts globally. And that's what we look at in the second part of the paper, where we think about the global effects of the Panama Canal expansion. First, however, we kind of look at the local effects around the Panama Canal, just to see how shipping activity changed around the canal, using again our satellite data. But then we turn to the global effects and think about which country pairs were actually benefiting from the improvement in shipping infrastructure around the Panama Canal. And that we do with a very standard difference in difference analysis, where we have bilateral trade growth on the left-hand side, and on the right-hand side, we take a double difference. So we basically estimate to what extent country pairs that used the Panama Canal prior to the expansion, compared to country pairs that didn't, experience differential trade growth pre and after the expansion. And what we find is sizable effect. So country pairs that were treated, so that use the Panama Canal, are found to have a 9% higher trade growth than the other groups of country pairs. And thirdly, we're kind of providing some numbers for the general equilibrium effects of this change in the shipping network using a canonical Eaton-Corton model. And there we find that also kind of at a global scale, these trade effects were significant. So world trade is found to have increased by 1.3% and world income by 0.02%. Also, what we find and believe is interesting is that the gains are really widespread. So many countries benefited from this change in Panama, whereas the costs were almost entirely borne by Panama alone. All right, in terms of the literature, I will be very brief and just highlight two things. So people have used satellite data to answer international trade questions. For example, Giulia Brancaccio and co-authors have looked at the bulk shipping industry with the help of satellite data. The bulk shipping industry is very different from the container shipping industry, so we think it's worthwhile looking at container shipping as well. And I'll point out a little bit later what the key difference really is. And then there's a recent paper by Ganapathy et al., who also looked at the container shipping network. These authors provide a model for the endogenous formation of these container shipping networks and analyze with the help of counterfactual experiments how important network effects are for global trade. Our approach is different in that we estimate the global effects that occurred as a response to an observed or an actual change to the network, namely the Panama Canal expansion, rather than relying on simulations. All right, then I describe in a bit more detail this data set. So the satellite data on container ship movement stems from the automatic identification system, which is a technology developed to track the movements of ships. And you can think about this simply as ships having a box installed, which sends a signal every 5 minutes, reporting the ship's position and also receiving other ships' signals. So the idea behind this technology was to ensure safe navigation of ships and better kind of planning possibilities for port authorities, etc. Important for us is that the International Maritime Organization requires this technology to be used by ships above a certain size cutoff, and this is low enough to make sure that basically all ships that you can reasonably use to transport containers are covered. So we are going to be able to describe really what the population of container ships is doing. In its most detailed form, the data can be visualized like this. So it allows you in almost real time, so in 5-minute intervals, to see the position of every ship globally. We do not have the data in that highly detailed form, but we have it in the form of port calls. So we have, in particular, all port calls in 2016, and the port call this port call dataset means that we observe an observation for every ship whenever it enters or whenever it leaves a port. So this allows us to construct the journey of every container ship in 2016 in terms of port visits. We bring in additional data, but I skipped it because I won't be able to talk about the parts of the paper that use it. And the other data we use is pretty standard. All right, then I jump into the data set and first tell you a little bit about the extent of the data set. So we're going to be talking about 5,000 container ships that were traveling around in 2016, and they visited 515 ports, or there are 515 container ports. And these ports are allocated across 150 countries. The first kind of stylized facts about the container shipping network that we highlight in this paper is the fact, which is kind of well known in this industry, that container ships operate on fixed routes. So you can think about them a little bit like buses. They have a fixed schedule specifying at what point in time they are going to arrive at what port for quite some time in the future. And exporters can book slots in these schedules. And in that way, the container shipping industry is very different from the bulk shipping industry, where kind of shipping capacity is allocated basically in the spot market in every port at every point in time. We see this fact that container ships instead have these fixed routes, for example, by comparing the number of ports that the ships pass to the number of distinct ports that they pass within a year. So we find, for example, that the median ship in 2016 visited 64 ports, but only 11 of them are distinct ports, implying that the ship tends to visit the same ports multiple times each year. For us, this fixedness of the routes is going to be important because our identification will rely on the network being stable, at least in the short run. Then the second fact that we highlight is the fact that shipping activity is highly concentrated. We see this, for example, by looking at ports and counting how many ships they have coming in. And the median port, as you see, has about 200 ships coming in, but the busiest port, which is the port of Singapore, has 7,000 times as many ships visiting in 2016. And we see the same kind of concentration when we look at routes, so port-to-port connections with ships traveling nonstop. The biggest or the busiest connection is just a lot more busy than, say, the median connection or the average connection. And this will also be important for our analysis of the Panama Canal expansion later on, because, well, generally it implies that local shocks can affect many countries. And the Panama Canal, which we are going to analyze later on, is one of these very busy connections in the network. The third fact related to the second one is that the network is generally very sparse. So we can see this by, say, counting the number of port pairs which do have a direct connection, so ships going nonstop. And we find that this is 4,000. And 4,000 is less than 2% of the total number of port-to-port connections that we have in the data set, which is roughly this number to the squared. So very, very few ports are directly connected with each other. And this fact holds up at the country level as well. So countries have multiple ports, so country pairs have multiple port-to-port connections. But when we count the number of country pairs that have at least one direct port-to-port connection, we find that this is only 6% of the possible number of country pairs, or the total number of country pairs that we have in the data, suggesting that indirect routes are very important. And for our analysis of the Panama Canal expansion, again, suggesting that it's very likely that many countries ship along this or on the same links within the network. All right, then our next step is that we think more about where these indirect routes go exactly. And what we do here is we exploit the fact that we see, besides these direct connections, we also observe the travel time, or the time that the ships take to complete such a nonstop journey. And then together with the shortest path algorithm, we can simply compute the fastest indirect route within this network of direct connections for all the country pairs that do not have a direct connection. And we're gonna from now on use this fastest connection as the most likely connection that country pairs are using for shipping. You might be rightfully concerned that this is a strong assumption because the fastest route is not necessarily the cheapest. However, people have produced support for the fact that the important cost factors in shipping, conditional on the network, which are fuel, labor, and capital, are highly correlated with time. So we believe we are not too far off with our approximation, but this is also work in progress. So we are kind of trying to back this up with more data. So in the paper, we provide a lot of summary statistics on these indirect routes. Here, I just want to tell you one fact, which is that when the most typical case in this container shipping network is that the countries' routes involve 2 or 3 other countries. So suggesting that exposure to third country infrastructure is an empirically relevant thing. All right, I'll, in the interest of time, spare you the summary of our stylized facts and go directly to our analysis of the Panama Canal expansion. So the Panama Canal, as I mentioned, is one of the really busy links in the network. And what happened with the expansion was that the Panama Canal was expanded by adding a third lane to the existing 2 lanes. So here I have a picture of the canal. In the background, you see the 2 existing shipping lanes, and then to the left, you see the new third lane that was built. And this new lane was bigger and wider than the existing one, making it possible for bigger ships to pass through. And in effect, this expansion led to a doubling of the capacity of the Panama Canal. Nicely, for the purpose of our paper also, is that it really happened in the middle of our data set. So we have a pre and a post period here. And in our event study that I won't have time to really go into, what we find is that exactly what was intended is also what happened. So after the expansion, the average ship size in the Panama Canal increased dramatically. But now I'm going to turn to the question how this local shock to the shipping infrastructure affected global trade. And
you have 5 minutes left.
Okay, perfect, thanks. We do this with the difference in difference estimation, where we have on the left-hand side Comtrade data on bilateral trade between I and J in quarter T. And we look at 1 year, so 4 quarters before the expansion and 1 year afterwards. And we relate this to this double difference indicator here, so a post dummy for the post period, and then a measure of exposure for country pair IJ to the Panama Canal, which exploits the route information that we backed out from the satellite data. And it is a measure at the port-to-port level. That is 1 if the shortest connection between the ports involves the Panama Canal. We add this up to the country pair level when countries have multiple ports by just using a weighted average, which means that this exposure measure ultimately lies between 0 and 1. And then as controls, we have as many fixed effects as we can, basically, and then time-varying controls, time-varying pair specific proxies for trade costs. And yeah, then let me go to the results and focus on the last column, which includes all the controls. So what we find is that our kind of treated pairs that use the Panama Canal prior to the expansion, experienced a 9% percentage point higher trade growth than the non-treated pairs after the expansion. And we do a bunch of robustness checks. We do a placebo test. So we look at whether when we assign the opening of the canal to June a year earlier or later, we don't find significant differences in the growth patterns between these country pairs. Right. Then the last step is that we want to think about the general equilibrium trade effects and also the welfare effects. So the difference in difference estimate gives us a relative trade growth, but says nothing about absolute trade growth. So, and we get that these general equilibrium effects with a fairly simple methodology, namely the Eaton-Kortum model. We add some even more simplifying assumptions to it. And as you probably all know, the Eaton-Kortum framework is a nice framework which where we can solve for the endogenous adjustments in prices, wages, and trade flows to a trade cost shock for particular country pairs. And so what is key for us now is to think about what the trade cost shock was for the country pairs using the Panama Canal. And here we also make our life fairly simple. So we take our difference in difference estimate, beta equal to 0.09, assume a trade cost elasticity of 5, and also assume that the trade costs of the non-treated pairs didn't change, which basically leads to an implied cost change of the Panama Canal expansion of -2%. And this assumption that the trade costs of the non-treated group didn't change relies really on the assumption that the network is stable in the short run. Yeah, then let me show you the results of our counterfactual analysis. So we plug this trade cost change into the EK model and then calculate the trade and welfare changes. And here you see the results. So on the horizontal axis, you see the welfare change measured in real income. And on the vertical axis, you see the change in trade. And what we find is that, well, Panama benefited, and basically all the neighboring countries of Panama benefited a lot as well as big economies like Canada and the US. And at the global level, the trade increase that we find is 1.3%, and the real income effect was also quite sizable at the world level and for many of the affected countries as well. So then I'll come to the conclusion. Basically, our conclusion is that the shipping network matters. So the data tells us that it is really non-trivial, it is sparse, and indirect shipping is important. So exposure to a third country infrastructure is important. Our analysis of a shock to one of the links in the network confirms that the trade effects can be big. I'm gonna end here and look forward to your questions.
Thank you, Inga. Thank you also for being perfectly on time. I've got two questions from the attendees, and then if there's other question from the panel of speakers, just raise your hands. I have also a question myself, so later on. So Jan Shimik is asking whether ships take indirect routes only because of geographic frictions, or indirect routes could be optimal because ships can load or unload goods at harbors that are located somewhere in between. This is a question by Jan.
So I need a little bit of clarification on the question.
Well, essentially, he's asking whether if there are the indirect routes that we are measuring is because of geographic frictions that the ships are finding. So typically, the fact, I assume that not every harbor can host every big container ship, or because there is let's say a convenient port in between that allows the ship to stop by, load and unload, and then therefore you will say you in a way optimize over the route. So you are by definition on an indirect route because there is an harbor in between, or whether this is geographical friction.
Okay, yeah. We don't really have anything to say about what determines the routes as we see them in the data. So I would point to the paper by Ganapati et al., who really analyze the cost factors behind the formation of the shipping network.
Okay. So Ritrabhata Bose is asking what type of algorithm you're using to calculate the shortest path, in particular whether you're using the Dijkstra algorithm or...
Yeah, we're using the Dijkstra algorithm.
Okay. Then I have a question from Beata and a question from Ralph in the panel. Beata?
So hi, Inga. You mentioned that many of these routes are scheduled, like buses. So now if more ships are going via Panama Canal, are there destinations that get less frequent calls? So is anybody losing? Now, when I look at your welfare calculation, I only think I saw Belize losing out. How come nobody else is losing?
Yeah, so I guess that is a comment on our assumption that the network is stable. So to the extent that in the short run, we don't see changes in the schedules, nobody will get disconnected. But this is something that our counterfactual analysis rests on this assumption. But I guess it could be generalized by taking into account the way the network changes and countries do get disconnected. The reason why Belize loses in our analysis is that this is a country without container ports at all, while its neighboring countries kind of get this trade cost benefit. Belize is losing out because it's losing in terms of relative competitiveness against its neighbors. So there are a few more countries that have the same feature, but the effects are so small that you can't really see it in this graph.
And Ralph also has a question.
Yeah. Thank you. I have two comments more than questions. So I think it's super interesting to think about the trade network. One application I would find particularly interesting is, what to check what happens in response to short-run disruptions. I mean, I think looking at the Panama Canal is interesting, but you might also think of a blockade, or you might think of a tsunami, or you might think of a strike at a particular port. Of course, you would need a different model then, because you need to have some frictions in the network formation and so on. But that is something I find really interesting. And then also, I believe there's a trend in the shipping industry similar to what's happening with aircraft or with airlines, that they're using smaller ships and more direct routes increasingly, rather than the huge ships like the A380s, so to speak, and do this like hub and spoke type system. So I think this would also be a really interesting trend to look at and see if you can probably not in this paper, but if you can, explain this somehow, rationalize this somehow. But it's really interesting.
Okay, thanks. We'll look in or talk about both questions and see if we can do something.
I think Gianmarco also asked for a question.
Yes, thanks, Carlo. Inga, so my question is more about the quantification and the choice of the model. So it seems to me, I mean, I just checked because I was curious, but essentially the top 4 players in the container business, so those who own the container ships, have the joint market share of nearly 60%. And you have a model, which is the Eaton-Corton model, in which essentially there is no transportation sector. And if you want, you have a transportation sector that maybe think as perfectly competitive, while here you have shippers that are probably optimizing a problem from the point of view of very concentrated oligopoly. And so I was wondering how that would affect your quantification exercise, whether you thought about that, whether you think what you have is an upper bound, a lower bound, or something with respect to what is the real measure.
So I definitely agree that it would be interesting to take the, say, imperfect competition in the shipping sector into account. In terms of how we should interpret our model results right now, I think we sort of have the perfect measure, because we back out the implied trade cost change from the data or from our estimation. So of course this relies on a ton of assumptions, like the trade cost elasticity of 5. But suppose the trade cost elasticity is true, then the observed trade changes that we see should really reveal to us the actual trade cost effect that happened.
Yeah, the point is that with oligopoly, I'm not sure that trade elasticity really makes sense if you have an oligopolistic shipping sector.
Okay, yeah, that is a point well taken. So it really rests on the assumption that we can use that trade cost elasticity.
But I mean, just curious, and since you have a nice case, a nice story here, my comment is really that maybe looking at it, giving a little bit more information on this shipping industry could be at least useful to figure out where we stand with these numbers.
Yeah.
I have Harald Fadinger also asking for the floor. Harald?
Yes, thanks, Inga. Very nice paper. So I have a question how your work relates to the work of James Farrer, who looks at the closing of the Suez Canal during the Israel, I think, Egypt war, and the impact that had also on growth, right? Can you somehow relate your numbers to his? Because he finds that for the Suez Canal, there are significant growth effects due to the decline in trade caused by the war.
Yeah, so I guess we could try to estimate this effect. So we could, like he did, we could use this sort of exogenous shock to trade costs and the corresponding trade increase to look at how countries' growth changed differentially. We haven't done that yet. yeah, we base on the only thing that the model gives us are these kind of static real income gains resulting from higher real wages, basically.
Because that could give you an idea how wrong our static trade models are in terms of welfare gains, right? If we don't consider any of these dynamic gains.
Yeah, I agree that
so it would be interesting to put that into the context of a dynamic structural model as well.
Yeah, yeah, I agree.
Okay, I have a quick comment. Then there is also another question by Rita Brata. If you allow me, Rita Brata, I will forward your question in written form to Inga in the chat later, so you can maybe discuss. I don't want to eat much on time. Now, my quick comment is that because of the Panama Canal expansion was announced in 2010, major harbors in the East Coast in the US already started dredging in order to allow for the new larger ships coming, which allowed large ships to come before the Panama Canal was open. So probably what you're getting here is a lower bound effect of the impact of the Panama Canal, because already since 2010, trade has increased in some of the big harbors in the US because of the announced effect of the Panama Canal. So this is something that you might want to consider, i.e. the size of the ships entering the different ports over time.
Yeah, I agree. That would be interesting if we could go back much more in time and look at the differential trade growth for the treated and non-treated country pairs.
You do have information on the dredging activities in every port, in every major port, so you do know whether this has changed over time.
Yeah, I agree. Well,